Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Aishah binti Muhammad FIKRY and I am from 1 BNT. Okay, first I would like to explain about question 3, which is the question asked to find r prime t and r double prime t for the following vector valued function. A, r bracket t equal to ti plus t squared j plus bracket t plus t3 cube close bracket k. First, write d over dt in the bracket ti plus t squared j plus bracket t plus 3 cube close bracket k and close bracket. Then we need to simplify the expression of d over dt bracket ti plus t squared j plus kt plus kt cube close bracket. So it will be d over dt bracket ti plus d over dt t squared j plus d over dt kt plus d over dt kt cube. So it will be I plus j bracket 2t close bracket plus k bracket t 3t square close bracket. So the solution is I plus 2jt plus k plus 3kt square. Then find the derivative of r double prime t equal to d over dt I plus 2jt plus k plus 3kt square. It is which we got from before answer. Then we need to use the differentiation rule. So we write d over dt bracket I plus d over dt bracket 2jt plus d over dt k plus d over dt 3kt squared close bracket. Next, find the derivative I plus 2j plus 2 bracket 3kt close bracket. So the solution is I plus 2j plus 6kt. Next, for the question B, r theta equal to sine square theta I plus cos 2 theta j plus theta square k. First, write r naught over bracket theta d over d theta bracket sine theta I squared plus cos 2 theta j plus theta square k. Then we need to simplify the expression of d over d naught expression of d over d theta sine theta I squared plus d over d theta cos 2 theta j plus d over d theta square k and close bracket. Next, we find the derivative. So we got 2 sine theta I minus sine theta j multiplied with 2j plus 2 theta k. So the solution is 2 sine theta I minus 2 sine 2 theta j multiplied with j plus 2 theta k. Then find the derivative of r double prime with theta equal to d theta bracket 2 sine theta I cos theta I multiplied with I minus 2 sine 2 theta j multiplied with j plus 2 theta k. So we need to use differentiation. So we need to use differentiation rule. So d over d theta multiply with 2 sine theta I cos theta I multiply with theta I and close bracket minus d over d theta bracket with 2 sine 2 theta j multiply with j and close bracket plus d over d theta multiply with bracket 2 theta k. So the solution will be 2 cos 2 bracket theta I minus 4 cos 2 theta j plus 2 theta k. Next, for the question 7, the question is given the vector value function r bracket t equal to 2 sin ti plus 2 cos tj plus tk. Find the unit tangent vector, principal unit formal vector, binomial vector, and curvature at t equal to pi constant. So, given r bracket t equal to 2 sin ti plus 2 cos tj plus tk, where t is pi constant. We found r prime t is equal to 2 cos ti minus 2 sin tj plus k. The absolute value of r prime t is square root of 2 cos t squared minus 2 sin t squared plus 1. So, then solve that. We got square root of 4 cos squared t plus 4 sin squared t plus 1. Then we got square root 4 plus 1, and the solution is square root 5. Next, find t bracket t. So, we need to write r bracket t over the absolute value of r t. So, we replace the equation above, which is 2 cos ti minus 2 sin tj plus k over square root 5. Then, find r double prime t. We got negative 2 sin ti minus 2 cos tj. After that, we write the absolute value of r double prime t, which is square root negative 2 sin t squared plus negative 2 cos t squared. Solve the equation above. We got square root 4 sin 2 square root 4 sin square t plus 4 cos square t. We got square root 4, then the solution is 2. After that, find n bracket t, which we write r double prime t over the absolute value of r double prime t, which is negative 2 sin ti minus 2 cos tj over 2. Meanwhile, to find BT, we need to multiply value of t bracket t with n bracket t. So, it will be I bracket negative 2 over 5 sin t multiply with 0 plus cos t multiply with 1 close bracket minus j bracket 2 over square root 5 cos t minus multiply with 0 plus sin t multiply with 1 close bracket plus k bracket 2 over square root 5 cos t minus 0 multiply with 0 minus cos t plus sin t multiply with negative 2 sin t over square root of 5 close bracket. So, solve the above equation. We got I multiply with cos t minus j multiply with sin t plus k multiply with negative 2 over square root of 5 cos t squared minus 2 over square root 5 sin t squared close bracket. So, the solution is I cos t minus j sin t plus k multiply with negative 2 over 5 square root of 5 cos t squared minus sin t squared. So, the curvature at t equal to constant so the curvature at t equal to pi constant is the absolute value of r double prime pi constant equal to square root 4 sin squared pi constant plus 4 cos square pi constant. So, settle the equation. We got square root 4 multiply with 0 plus 4 multiply with 0.54. We got square root 2.16. So, the solution is 1.47. So the question given is, the velocity of a particle moving in space is v bracket t equal to e to the power of t I plus 4tj plus sine pi tk. Find the particle's position in terms of t in r multiplied with 0 equal to 2i minus j plus 1 over 5k. So, we integral v t dt equal to bracket integral e to the power of t dt multiplied with I plus integral 4t dt multiplied with j plus integral sine pi dt multiplied with k. So we get Vt equal to e to the power of t plus multiplied with I plus 4tj plus sin pi tk. Next, Rt equal to integral Vt dt. Simplify Rt equal to integral e to the power of ti plus 4tj plus sin pi tk dt. We got Rt equal to integral, we get strict inequality e to the power of t 4t sin pi t dt. So we will get Rt with strict inequality which it is mean less or greater than e to the power of t plus c1 2t square plus c2 o plus c3. First, for c1, the equation is e to the power of t plus c1 equal to 2. So c1, move the expression to the right hand side and change its sign. We got c1 equal to 2 minus e to the power of 0. Then the order the terms and the solution for c1 is c1 equal to 1. Second, for c2, the equation is 2t square plus c2 equal to negative 1. Replace 0 into the t to get the solution. 2 multiplied with 0 square plus c2 equal to negative 1. So the solution will be c2 equal to negative 1. Third, for c3 is 0 plus c3 equal to 1 over pi. So c3 will be 1 over pi. Therefore, R3 is strict inequality which it is mean less or greater than e to the power of t plus 1 2t square minus 1 1 over pi. So Rt will be e to the power of t plus 1 multiplied with I plus 2t square minus 1 multiplied with j plus 1 over pi multiplied with k. Next, assume that all spill from a ruptured tanker spreads into a circular pattern whose radius increases at a constant rate of 2 feet over second. How fast is the area of the spill increasing when the radius of the spill is 60 feet? So we know that the constant rate is 2 feet over second and radius 60 feet. So we know the equation is area equal to pi r square. So we write dA over dt equal to 2 pi multiplied with r multiplied with dr over dt. So we write 2 pi multiplied with 60 multiplied with 2. So we got 240 over feet to the power of 2 over second. Next, question number 2 is a 20-meter ladder leans against a wall. The top slides down at a rate of 4 meter second negative 1. So, how fast is the bottom of the ladder moving when it is 60 meter from the wall? So, we know that y, x, and 20. So, tan theta over y over x. Then, sec squared over 2 multiply with 2 theta over dt equal to x multiply with dy over dt minus y multiply with dx over dt over x square. So, we know that sec squared theta is 20 over 16 squared. Multiply with d theta over dt. So, we got x. We know that x given is 60 meter from the wall. So, we substitute 16 into the x, multiply with dy over dt, minus, so how to find y? So from here, we know that 16 square plus y square over equal to 20 square. So y square is 144. Therefore, y equal to 12. So substitute 12 into the y, minus 12, multiply with dx over dt, over 16 over 2. We substitute 16 with value, we substitute x with value 16. So 20 over 16 square, multiply with d theta over dt equal to 16, dy over dt, minus 12. So how to find dx over dt? Dx over dt is given, which is a rate of 4 meter second negative 1, equal over 16 square. So we write 20 over 16 square multiply with d theta over dt equal to 16 multiply with dy dt. So how to find dy dt? Dy dt is 2x multiply with dx over dt plus 2y multiply with 2y dt. So we know that 2h multiply with dh over dt. So 2 multiply with 16 multiply with 4 plus 2 multiply with 12 multiply with dy over dt equal to 0. So we know that dy over dt is negative 16 over 3. So we substitute dy dt with a value negative 16 over 3 minus 12 multiply with 4 over 16 square. So we get d theta over dt is equal to negative 1 over 3. So the solution is negative 0.3333 radian per second.